Imagine building a chatbot to answer questions about company policies. You ask, what's the company's policy on remote work for new hires? The system uses a Retrieval-Augmented Generation pipeline. It converts your question into a vector, a list of numbers representing its meaning, and searches a database for similar vectors. The vector search returns the top 10 most similar documents, some about remote work, others about onboarding or even outdated memos. But none directly answer your specific question. The crucial policy might be buried or missed entirely. This highlights a key problem. Vector search finds documents that are related but not always truly relevant. The system might pull in lots of noise, confusing the language model and leading to vague or incorrect answers. We need a way to refine this broad search, to focus on what really matters. Enter the Reranker, a specialist that examines the top results and identifies which ones are truly relevant. With a Reranker, we can bridge the gap between similarity and true relevance. Let's see how this works. To solve this, we use a two-stage retrieval system. First, a fast vector search pulls the top 50 or 100 documents related to the query. This stage prioritizes recall, making sure the right answer is somewhere in the batch even if there's noise. Next comes the reranking stage. The Reranker takes the initial list and, using the original query, analyzes each document in detail. It assigns a nuanced relevance score, far beyond simple similarity. Think of it like a research assistant. First, they grab every book about ancient Rome. Then, they find the exact pages on Roman legionary life. The Reranker is that meticulous assistant, surfacing only the most relevant results. This two-stage process combines speed with precision. The final re-ranked list is passed to the language model. With curated context, the model generates more accurate, helpful answers. Re-ranking dramatically improves the quality of Retrieval-Augmented Generation. Now let's look at how Rerankers work under the hood. The initial vector search uses a bi-encoder model. Here, the query and documents are processed separately into vectors, making search fast and scalable. But this separation means the model can miss subtle connections. It never sees the query and document together. It's like judging chemistry from individual photos, not a photo of the couple together. Rerankers use a cross-encoder architecture. The cross-encoder takes both the query and a candidate document as a single input, analyzing their interaction in detail. This joint processing allows it to spot nuanced relevance, not just general similarity. The cross-encoder outputs a relevance score for each query document pair. While slower, it's perfect for re-ranking a small set of candidates. That's why we use bi-encoders for broad search and cross-encoders for precise re-ranking. Rerankers solve several core RAG challenges. First, LLMs have limited context windows. Stuffing in too many irrelevant documents wastes space and drowns out key details. Rerankers ensure only the most relevant information makes it in. They also handle vocabulary mismatches, connecting queries about pay to documents about compensation. By analyzing query and document together, Rerankers understand nuanced relationships. They help disambiguate broad queries, surfacing the most directly relevant answers. Benchmarks show Rerankers boost metrics like mean reciprocal rank, moving the right answer to the top. This isn't just academic, it means more accurate, trustworthy answers for users. Rerankers transform RAG from a decent retriever into a high-precision answering machine. But which Reranker should you use? There are several popular Reranker models. Cohere Rerank is a high-performing, easy-to-use API. Great for general use, but it's a managed service. For open-source BGE Reranker models from Beijing Academy of AI are strong contenders available on Hugging Face. They offer control and cost savings but require more setup. Cross-encoder/MS Marco models are classic fine-tuned on real web queries and widely used for web search tasks. Mono T5 adapts the T5 transformer for re-ranking, outputting true or false for relevance. Colbert V2 uses late interaction for fast, accurate re-ranking, balancing speed and precision. Each model has trade-offs in performance cost and complexity. Choose based on your needs. Managed service for ease, open source for control, or advanced models for speed. Now let's see how to put Rerankers into practice. Adding a Reranker to your RAG pipeline is simple. First, retrieve a broad set of candidates, say the top 50, from your vector database. Next, pair each candidate with the original query and pass them to your Reranker model. Collect the relevance scores, then sort and select the top 3 to 5 documents. Feed these to your language model for the final answer. For best results, tune how many documents you retrieve and re-rank. Too few, and you might miss the answer. Too many, and re-ranking slows down. Keep document chunks concise for better re-ranking. Re-rankers are essential for robust, accurate RAG systems. Think of vector search as the librarian pointing you to the right aisle. The re-ranker is the expert who hands you the exact book and page you need. With re-rankers, your AI delivers not just similar information but the right answer.